Good day, ladies and gentlemen, and welcome back to the Anti-Science Theory. And today we're going to be looking at organic chemistry. Okay, so today we're going to be looking at organic chemistry, and this is one of my favorite topics on the grade of chemistry, if I do say so myself. And I really hope that throughout the entire topic, we'll have fun of our very own. It's quite a fun topic, quite a topic that requires a lot of logical yet also quite obvious reasoning at some time. But I hope you guys will enjoy just as much as I do. But before we get into this, please don't forget to throw in a like, a comment, and a share right there. Share to your favorite friends, to your families, to your parents if need be. Just let them know. Give them a reason why. I mean, show them why it is that you are doing so well in matric. Don't be that gatekeeper of a friend, man. I mean, no one likes a gatekeeper, right? But any comments that you need to say, anything you'd like to add, any questions you guys actually have, then please make sure to write or to post all of that in the comment section. And as soon as I get a chance, I shall then reply to them in ways that I can. But I will most definitely get to all of you guys. Whatever I have to answer will be answered, and hopefully I will have done justice in answering any of those questions. But without any further waste of time, I think we can just talk about everything organic chemistry, which is, by the way, a very large topic. It's very huge. It's quite a cumbersome of a topic. Um, it consists of three parts. First, and those three parts are very easy to understand if you give it a chance, and more practice makes it easy along the way. But I want you guys to understand something. That as big as this topic is, literally acing the topic alone in a question paper puts you in a pass for the paper itself. But obviously, you know your own strengths, and you can't obviously settle for just doing well in the paper or for just passing the paper. You need to do extremely well. That is also do well in the rest of the topics in the paper that are to come. But in general, organic chemistry is just quite a very nice topic itself, and it's very easy to understand that it's very simple, if I do say so myself. It's quite a lot of marks, and it is also quite a lot of work. But trust me, you'll enjoy it as time progresses. But nonetheless, right. So what do we mean when we're talking about organic chemistry? Besides the word chemistry, what is something? What do we mean when we say something is organic? Well, in simple terms, when something is organic, we then say it contains the element carbon, right? Contains the element carbon. I don't know why I have so many brackets going on around that carbon, but it contains the element carbon, right? So what's so special about the element carbon? Well, we do know that it contains the atomic number 6, it contains the atomic mass number 12, and all of those gory details that you should know about a carbon element, but that's not important right now. What you need to understand that when you're looking at organic chemistry, when you say something is organic, then we're talking about something that contains the element carbon. Inorganic would obviously be true. Well, in its definition, yeah. Anyway, so what you need to get is that in every aspect under organic chemistry, we're going to be dealing with a lot of compounds that consist of carbon, regardless of whatever comes after, regardless of the fact that it can consist of other elements. But the main element that it would have is carbon, right? Okay. So right. So with organic chemistry, like I said, when you say something is organic, it consists of the element carbon. And also a very important thing that you must understand is that the element carbon is from grade 11, you guys learned about the VSEPR, right? The valence shell electron pair repulsion. And you learned about elements like carbon that are tetrahedral. That is, carbon can form literally four bonds. But why is that? Because of the fact that carbon consists of four valence electrons. You guys must know what valence electrons are. But because carbon consists of four valence electrons, that would be an electron there, another electron there, another one right there, and another one right there. That would mean that carbon can literally form four bonds with any other element, whether that element is diatomic or not, or whether that element makes double bonds or not. But at the end of the day, you must remember that carbon can only form four bonds. Immediately when you speak about carbon with more than four bonds, then you need to then introduce a formal charge. But that's not important in this particular syllabus. Okay, so now I'm then going to say, with the element carbon, we know that it can only make four bonds because of its tetrahedral nature, right? What you must understand is that when we're looking at chemistry, we speak about what we call hydrocarbons. Now, what exactly is a hydrocarbon? A hydrocarbon, just as the name says, is a compound that consists of two elements, mainly your hydrogen and your carbon. So a hydrocarbon only consists of hydrogens and carbon. Immediately, ladies and gentlemen, immediately when you don't have a compound consisting of only carbon and hydrogen, then you're no longer dealing with a hydrocarbon. So immediately when I have a compound of carbon here, so let's say we have um, a methyl something, right? So I have a bond here with hydrogens, and then I just decide to say I now bond this with chlorine. This is methyl chloride. And when you have methyl chloride, because of the fact that you have a halogen, you can't say this is a hydrocarbon because it doesn't consist of only hydrogen and carbon, but it consists of hydrogen, carbon, and chlorine. Right? So that's a very important thing to remember. Hydrocarbons are compounds that consist of only carbon and hydrogen, nothing more. Okay, now that we've gotten that out of the way, it's very important for you to know these terminologies, ladies and gentlemen, and to understand what these terms basically mean. Right. And then we speak of what we call a saturated hydrocarbon. Okay. Or a compound that is saturated. What do we mean when something is saturated? Well, when something is saturated, we are basically saying that it consists of single bonds. It must consist of single bonds between the carbon atoms. Very, very important. Between the carbon atoms. What does this mean? So between two adjacent carbons, or rather between adjacent carbons, doesn't necessarily have to be two, you must have single bonds between those carbons. If I have carbons like this, so if I have carbon here, a carbon here, a carbon here, and a carbon here, these are all carbons that are adjacent each other, right? And since these are next to each other, between these bonds, between these carbons, I must only have single bonds. Immediately when I have a bond that is not single, for example, I have a bond like that, this then goes against the fact that this would be called a saturated hydrocarbon. Why would I not call this saturated? Because it does not consist of a single bond, but instead it consists of a double bond. Huh. So when something consists of a single bond between the carbon atoms, please, ladies and gentlemen, that is a very important part. Between the carbon atoms. The only bonds we look at when we want to say that something is saturated or unsaturated, you need to focus on the carbons. Do not look at any other element that is not carbon. For example, if I decide to say I have a carbon bonded to an oxygen and bonded to another carbon and bonded to another carbon, and then they ask me, is this compound saturated? Yes, it's saturated. Why? Because there are single bonds between the carbon atoms, not between the carbon and the oxygen atom. Yes, don't get me wrong, there is a double bond between the oxygen and the carbon atom. However, that is not our main focus. When we define a saturated compound, we say it's saturated because of the fact that it contains single bonds between the carbon atoms, not carbon with some different element. Please don't forget that. That is very important. So our focus is on the carbon atoms, right? And then we look at something else, which is what we call the unsaturated hydrocarbon. So when something is unsaturated, it's the opposite of saturated. That is, something is unsaturated, then it consists of double bonds or triple bonds between between carbon atoms. Sorry, I just had a tweak right there because I was thinking of something. Between the carbon atoms. If you're wondering and you're quite curious of what I was thinking about, I was thinking about the fact that if I write double or triple, then it just literally doesn't include the fact that when I have something like this, this is C2. C2 has one, two, three, four valence electrons and it has four bonds between it. This is obviously not saturated, right? So that's an unsaturated, it's not a hydrocarbon, but it is an unsaturated compound. But also the fact that it's best if you just say unsaturated carbons consist of two or more bonds. Let's just keep it at that. But please understand, very important disclaimer. When I write down definitions, I don't write definitions verbatim from the exam guideline. That is, I don't write definitions as is or exactly from the exam guideline. These are just summarized definitions. But for every definition in an exam, when you're preparing for an exam, please make use of the exam guidelines because those ones have more accurate definitions. So don't take mine and just depend on it and just say this is what I'm going to write in the exam. No, do not do that. This is just me summarizing everything for the sake of comprehension. Okay, so we've looked at hydrocarbons. We've looked at what it means for a compound to be saturated. We've looked at what it means for a compound to be unsaturated, right? So just a quick example. So just to give you a few quick examples on saturated and unsaturated compounds. So if I'm looking at compounds that are saturated, I would be looking at the following. I would be looking at a carbon, carbon, carbon with the hydrogens, hydrogens, hydrogens. This is, by the way, a hydrocarbon. Why do I say it's a hydrocarbon, ladies and gentlemen? What do you think that is? Pause the video, think about it. If you say I say this is a hydrocarbon because of the fact that it consists of carbons and hydrogen atom only, then you must give yourself a high five. Get yourself a drink, man. Get yourself something to feel good about yourself. Okay, so we have the first example of a hydrocarbon, and that is saturated. Why? Because between the carbon atoms, I have single bonds. Notice how I'm not looking at these ones between the hydrogens because I don't care about those. When something is saturated, I need to look at the carbons. I need to look at the bonds between carbons, right? Another compound would be a carbon bonded to another carbon, bonded to another carbon, that's 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 bonded to another carbon. So notice how I have single bonds between every carbon, right? Aha. So we have single bonds between every carbon. Just to make this a little more interesting, let's just do this. So what I'm going to do is I'm going to give you guys a few compounds, and we're going to do it together. We're going to say which one is saturated and which one isn't, right? So I'm going to have a compound. Um, okay, right. So let's see. Let's start with the first carbon. So with the first compound, this is compound one. So with compound one, what do you guys think? Carbon, is it saturated or unsaturated? Unsaturated, yes. I'm kidding. I, there's probably just that one person sitting there just wondering, how is that even such? How's that unsaturated? What are you talking about? But yeah, that was just a little play on you guys. But yes, if you think that's saturated, you are correct. Why? Because I have single bonds between the carbon atoms. Single bonds between the carbon atoms. That means it's saturated, right? If I look at this one, I have a single bond, yes, single bond, yes, single bond, yes, but I have a double bond. Immediately, when you don't have single bonds only, you can't say something is saturated. Please, ladies and gentlemen, a compound cannot be saturated and unsaturated at the same time. Those two events are mutually exclusive. Please, 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 please. You cannot say that they have the same, the a single compound is both saturated or unsaturated. That is not a case that you will have. Can either be one of the two. It can't be both. Okay? So, in this particular case, what does this mean? Already, when I say double bond, like this one here, I can then not classify my compound as being saturated. Therefore, my final answer here would be unsaturated. So immediately once you see a double bond or a triple bond or a bond that's not a single bond, you can't say something is saturated. You then need to conclude that it's unsaturated. Right, so let's look at this one. Is it a single bond? Pause, think about it. Let's see. Yeah, let's see. We don't know. You said saturated, you said unsaturated. We don't know. Let's see. So I have my carbon atom here. I see a single bond. Aha, I see a single bond. Okay, I see a single bond. I see a single bond. But I see a double bond. Therefore, this one must be unsaturated because I already see a double bond. Immediately when I see a double bond, I can't say that something is saturated. So this is unsaturated. Hope you guys agree with me on this one. Okay, there's also another joke. This is not unsaturated. But why is it? Why is it not unsaturated? Let's see. What do we say when something is saturated? Something that is saturated has single bonds between the carbon atoms. Please, very important. So in this case, I have a single bond, but that's between a hydrogen and an oxygen. I have a single bond that's between a carbon and a hydrogen. I have a single bond that's between a carbon and a hydrogen, and I have a double bond between a carbon and an oxygen, a single bond between an oxygen and a carbon. I have a single bond between a carbon and a carbon. What is our main focus, ladies and gentlemen? The main focus is only on carbon bonds, sorry, on carbon atoms. Do you see two carbon atoms that have a single bond between them? Yes, that is this carbon here and that carbon there. Are there any other carbons we should be concerned about? No. Therefore, this compound is saturated. Okay, right. So I come to the last compound here. So the last compound, is it saturated or unsaturated? Oh, this one is so obviously not saturated because of, look at this. Triple bond, double bond, automatically this becomes unsaturated. Right, I hope you guys get the idea of saturated and unsaturated compounds. Very simple. Please do not forget that. It's very important. Right. Okay. And then now we look at what we call molecular, structural formulae. Okay. So these are two types of formulas, right? You have two types of formulas, molecular formula and a structural formula. Okay. So what is a molecular formula? Molecular formula is a formula that shows, sorry, does not show. Remember, this is not the actual definition. This is just a summary of what we mean. Does not show the bonds between, does not show the bonds between atoms. It doesn't, you're not restricting it to only being a carbon atom. We're just speaking about any atom of involved in any compound. if you don't show the bond between atoms, then we say we have a molecular formula. Then what is a structural formula? Structural formula is the opposite. A structural formula shows the bonds between atoms. And what you need to know is that you must know that these two, molecular and structural formulae, have a very good relationship with each other. Big, big friends. For example, I can move from a molecular formula all the way, I can move from a molecular formula to a structural formula, or from a structural formula to a molecular formula. Right? So let's do a couple of examples to see what that means. So what do I mean when I say something is a molecular formula? Something that is a molecular formula is something that takes the form of C, let's say C2H7O12. For example, let's just take glucose. Glucose is C6H12O6, right? That's glucose. Okay, so notice how. Do you guys see any bonds between these atoms? No, you don't, right? So this would be a molecular formula. Why? Because the molecular formula does not show the bonds. If you have something like H2O, H2O, that's your molecular formula because it doesn't show any bond. CO2, that's a molecular formula. It doesn't show any bonds. But what does a molecular formula do? What does it show? It shows the number of atoms, sorry, it shows the number of atoms in a compound. Or rather, it shows the number of individual atoms in a compound. For example, in CO2, this tells me that there are two atoms of oxygen. So it shows me the number of individual atoms in a compound. H2O, this tells me that I have two hydrogens. O6, this tells me I have six hydrogens, right? So this is what we mean when we speak about a molecular formula. That's very important. But like I said, you can move from a molecular formula to a structural formula. What does a structural formula do? Shows the bonds. So if I have a compound like let's see, if I have a compound like CO2, so if I decide to, this is my what? My molecular. So how do I move from a molecular to a structural? I then need to say, how do I draw this thing? This is a carbon, an oxygen, and a carbon. So sorry, carbon, oxygen, carbon. So that's 1, 2, 3, 4, 1, 2, 3, 4. Okay, right. So I would have this carbon and this oxygen there. Okay, I think I'm just gonna have to use different colors so that you can see what I'm doing here. Um, but I want us to just quickly do this. So I'm gonna say COC. So I'm gonna say let's just say X. 1, 2, 3, 4, 5, and 6. Okay, and then this one has 1, 2, 3, 4. 1, 2, 3, 4. Okay, so I then need to fix my compound here. So my final Lewis dot structure. I hope you guys still remember how to do Lewis dot structures. So this then would be okay. I already see my lone pair. So that's 1, 2, 3, 4 with my lone pair right over there. And then I would have 1, 2, 1, 2 with the lone pairs over there. Right. So how do I write this with bonds? This would then become C double bond O double bond C. So notice something. This, ladies and gentlemen, is my structural formula. Oh, sorry, this is C2O. It's supposed to make this CO2, not C2O. Um, but you get the whole idea behind it. Really, let me just quickly do this with no waste of time. So if I have a compound like C2H6, this would be my molecular formula, no? Yes. So this would be my molecular formula. Then I move from the molecular formula to the structural formula. How would the structural formula look? So I'm moving from molecular to structural. This would mean that I would have how many carbons? Two carbons. So this would be one, two. And then how many oxygens? I have six. So that's one, two, three, four, five, six hydrogens. So these are the number of hydrogens that I have. But question, notice how we've moved from molecular to structural, but can we do the opposite? Can we move from structural to molecular? Yes. If I have an example here like this, guys, by the way, I'll stop putting in the hydrogens because it's a bit of a waste of time. So I'll just leave empty spaces. Just know that these empty spaces that I've left here are for hydrogen, right? And I move, this is my structural, right? So this is structural. And how do I get to my molecular? I will then say, how many carbons do I have? I have one, two, three. So that's how many carbons? That's carbons, and I have three of them. And how many hydrogens? That's one, two, three, four, five, six, seven, eight. So that's hydrogens, eight. So I've moved from a structural to a molecular. Aha, hope you guys can see that. Okay, so these are very important things that you must remember. The structural formulae and your molecular formulae, these are all very, very, very important. Do not forget that. Please do not forget structural formula and molecular formula. Please don't forget saturated and unsaturated compounds. Those are very, very important. Okay, now, I just want us to get into a very few important things, right? I'm just going to call them important things. Important things. Okay, so for starters, as time progresses, when you do IUPAC naming and other things related to organic chemistry, there are going to be a few things that you must know. So for starters, you must know all your prefixes. These are very important when it comes to IUPAC naming. So how many prefixes do we have? We initially had 10, but most teachers want you guys to focus on only 8. So the first one is your meth. What is a prefix? A prefix that is something that comes before the actual root word, right? So meth is the prefix. Meth basically means that you have one carbon. Okay. Then you get to the second one, which is eth. Eth means that you have two carbons. Then you have prop. Prop just means that you have three carbons. Guys, please make sure that you have all of these notes. These are very important. Um, Meth, eth, prop, bute. Bute just means that you have four carbons. Then we have pent. Pent. What do you think pent means? Five carbons, right? But why five? Because remember in grade two, you learned about shapes, 2D shapes, pentagon, hexagon, nonagon, and all of that, right? So the next one would be hex. Like I just mentioned, what do you think hex will be? Yes, hex will be six carbons, right? And then we get to hept. Hept just means that we have seven carbons. And then we get to oct. like the octagon cage of the UFC, 8 carbons. Then we have non, which means 9 carbons. And then we have dec, which means 10 carbons. So these are all the prefixes that you need to remember. Please do not forget these. These are very important when it comes to IUPAC naming. Okay? And then I want us to get to the next part, which is what we call the alkyl groups. Alkyl groups are also called your substituents, or you can also call them your branches, your side chain, your side branches. Okay, so this is what we have, our alkyl groups. Now there are different types of alkyl groups that we have, right? So for example, we have the first one, just use a different color, this is green. So the first alkyl group would be your methyl group. What does the structural formula of the methyl functional group look like? Sorry, the methyl group, it's C123. Right. And then we then speak about our ethyl. The ethyl group looks something like this. Right. And then we have the other one, which is our propyl group, which is something like this. One, two, three. Okay. Oh, and by the way, these squiggly lines in blue just mean I have a long carbon chain. It just talks about the longest carbon chain. So these are side branches. So remember that these things are side branches, right? So these things are side branches. That means they come on the side. They come on the side, right? So say for example, I have a compound of C, 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 C. Then I have something here with CH3. This entire thing here is the something that is the very same thing that I used with squiggly lines. I represented this whole chain with squiggly lines like this. That's what I did on this compound of the methyl, right? This then shows you that CH3 is on the side. That's why we call it a side branch, right? It's a branch, it's a substituent, right? This is our CH3, our methyl, right? So you must know all of these substituents. Please know the difference between a methyl, an ethyl, and a propyl. That's very important to note, very important. And how important are these things? That's a question at hand. How fundamental are these? I mean, you can't say they're important. I mean, what's the depth of the importance? Well, if you think about it, when you say something, I mean, also it's very important to understand why do we call something a methyl group? Because of the fact that it has the prefix metl and it has 1 carbon. The metl tells you how many carbons it has, right? Remember the prefixes. Met8 or meth basically means 1 carbon. Notice how this one has 2 carbons and we're calling it ethyl. But the ETH tells us that it has 2 carbons. What does prop tell us? Prop tells us 3 carbons. So this then we have one, two, three carbons. So this then tells us that this is propyl because of the prop that tells us that it has three carbons. So why is this important? Once again, this is very important when it gets to IUPAC naming. Your alkyl groups are very important, ladies and gentlemen. Alkyl groups are important when it comes to IUPAC naming, when it comes to organic physical properties, your intermolecular forces, right? Um, so please keep in mind that these things are very important. You'll see the importance of these things as we get deeper and deeper into organic chemistry. Okay. And then the last thing that I want to mention is your what is this? Your prefixes for alkyl groups, right? Remember we had normal prefixes, but now I want to look at prefixes for alkyl groups. So what are prefixes for alkyl groups? So these come when what happens? So when I have a certain compound C, 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 I see, I see. Okay, sorry. And then I have a branch here of CH3. And then I have another one here of CH3. And then you ask yourself, oh, and I forgot to write down the molecular formulae for these things. Guys, looking at the structural formula or formulae for all of these alkyl groups, what do you think the molecular formulas will be for each of them? Look at the number of carbons and hydrogens. So what will it be for the first one? Yes, so that's CH3. For the second one, that's that's C2. How many carbons do we have? We have 1, 2, 3, 4, 5. So CH2C5. And then for the propyl, it's how many carbons? 3. And then how many hydrogens? That's 1, 2, 3, 4, 5, 6, 7. So C3H7. Okay, right. So in this case, I have two methyl groups. That is, I have this one here and I have this one here. Since that's the case, how many methyl groups do I actually have? Notice that I have two methyl groups. Now, in basic life and in other subjects as well, when something is two, what do we say? Besides the fact that it's a pair, what prefix do we use when we're trying to refer to something with that consists of two of itself? I don't know if that's grammatically correct, but if I have something, right, for example, and I have two of those things, what prefix would you typically use? Aha, yes, you said it. It would be your di prefix. So the prefix that we're going to look at under for alkyl groups will be your di, right? It will be your tri, and it will be your tetra. So what does di mean? Di means two, tri means three, tetra means four. So since I have two methyl groups, how many methyl groups do I have? Two. So instead of using the number two, I can just say these are, aha, dimethyl. Di already tells me there's two of them. Aha, that's very important, guys. If I decide to add another one here, another CH3, another methyl group right there. Then I decide to add another one there, another CH3, another methyl group. Notice that I have two more, two more. How many of them do I have now? I have four of them. So I have how many methyl? So I have methyl groups, but of those methyl groups, I have four. So instead of writing four, I can write, aha, tetra. So this is tetra methyl. So that's very important to understand, ladies and gentlemen. It's a very important thing. Do not forget these things. Do not forget everything that we've covered in this video, because these are all important for the next video where we'll start looking at um, IUPAC naming. Okay. But from me to you, I shall leave everything here, and I shall see you then in the next video. Please don't forget to like, comment, share, and subscribe to this if you are getting the content and everything is going so nicely so far. Subscribe if you're new and join the family. And trust me, we are going to have a blast this year. But nonetheless, from me to you,